Uh, Hello and good day. I'm Luyalan Pakana from Group 12, and I'm here to report our topic, network troubleshooting. The first up is network documentation. So let's start. Documentation overview. As with any complex activity like network troubleshooting, you will need to start with good documentation, accurate and complete. Excuse me. Network documentation is required to effectively monitor and troubleshoot networks. So, common network documentation includes the following: physical and logical network topology diagrams, network device documentation that records all pertinent device information, and network performance baseline documentation. So, all network documentation should be kept in a single location, either as hard copy or on the network on a protected server. Backup documentation should be maintained and kept in a separate location. This documentation is very essential to network troubleshooting, since when a network problem occurs, these three that I have mentioned uh, will give basically information on how to respond to a network problem in the network. So as these three also, I will be also discussing in the following. So first up is network topology diagrams. So network topology diagrams keep track of the location, function, and status of the devices on the network. Basically, there are two types of network topology diagrams, which is the physical topology and the logical topology. So first up, let's start physical topology. Excuse me for having a bit of a hard time navigating, since I'm only using a cell phone. So a physical network topology shows the physical layout of the devices connected to the network. You need to know how the devices are physically connected to troubleshoot physical layer problems. Information recorded on physical topology typically includes the following. Device name, device location, interface, and port use, and cable type. So basically, physical topology is how physically the devices are connected together and when are they connected as well. We have these are the four needed information that needs to be documented, which is device name, device location, interface, and ports use, as well as cable type. Let's go to a sample of physical network topology diagram. So as you can see here, it's basically a network with relevant information on devices, the cables, and etc. So let me just scroll down here. Okay, so basically that's a sample of physical topology, physical network topology. So next is the logical technology, topology rather. In here, a logical network topology illustrates how devices are logically connected to the network. This refers to how devices transfer data across the network when communicating with other devices. The information recorded in logical topology is device identifiers, IP addresses and prefix links, interface identifiers, routing protocols, static routes, layer 2 information, sample is VLANs, trunks, and Ethernet channels. So let's see here an example of logical topology. So here is an example of a logical topology, which is IPv4, by the way. When you go to work, you need to familiarize physical and logical topology, or document it if ever there is no physical no documentation, because sometimes there's already documentation on the network, but if it hasn't, when you are in work, when you when you know that there's no documentation, you just simply create a documentation yourself by creating physical topology and logical topology. So next is network device documentation. So basically this is how you should document all different devices information. So here are the tables, the interfaces information, the model, description, location, iOS, and license. So this is basically the right way to document the network, so you can have a easy go of getting information from the network. So let's see here as well. So the ports, this relevant information about the ports. So description, access, VLAN, trunk, Ethernet channel, native, enabled. So basically that's how you should follow this format on documenting router information, port information, and etc. So now we go to establishing a network baseline. So the purpose of network monitoring is to watch network performance in comparison to a predetermined baseline. To establish normal, a baseline is used to establish normal network or system performance to determine the personality of a network under normal conditions. So basically, a baseline is you basically want to monitor your network on what is normal and what is abnormal operation, or also network traffic as well. So a network baseline should answer the following questions. Basically these are the things that will be answered when you create a network baseline, so or establishing rather. So a network baseline should answer the following questions: how does the network perform during a normal or average day? Where are the most errors occurring? What part of the network is most heavily used? So these are basically samples of what establishing network performance baseline answers. So basically it's like a monitoring system in the network in which it checks or monitors the network with regards to the normal operations as well as the traffic. If basically there's an traffic or abnormality in the network, you basically will know that there's an abnormality, and so in which because of that you can respond or basically know that there's an abnormality, and then you can respond to that abnormality or traffic, so there will be no more problems in the network and it can easily be solved faster. So here is measuring the initial performance and availability of critical network devices and links allows a network administrator to determine the differences between abnormal behavior and network performance, as well as network growth or traffic patterns change. So as I've mentioned before, these quotes here, or these sentences here, in short, is basically you monitor the network, its operations, its network performance, traffic patterns, because of this you may notice hidden changes in the network, which may lead to problems in your network. So this network baseline is very essential in network documentation because it monitors, again as I've said, it monitors the network operations, abnormalities, and traffic. So step 1 in creating a network baseline is determine what types of data to collect. So basically is you select a few variables that represent defined policies, and also you start with an interface and CPU initialization, so you can use this baseline to monitor traffic. Also checks when an abnormality appears in the network. So basically this is how you know what type of data to collect. So next step would be identify devices and ports of interest. So basically, you will use the network topology to identify those devices and ports for which performance data should be measured. Device and ports of interest include the following. So network device ports that connect to other network devices, servers, key users, anything else considered critical to operations. So the network topology that we will be using here is logical network topology, since basically uh, it can be useful in identifying key devices and ports to monitor. Logical topology is suitable in this step 2, since it can identify ports and also identify key devices and monitor them basically. So here, as you can see in the topology here, this topology is basically a logical topology. It monitors the ports here and also identifies the key devices. So next is the most important step is determining the baseline duration. So the length of time and the baseline information being gathered must be long enough to determine a normal picture of the network. So it is important that daily trends of network traffic are monitored. So basically, this is the determining factor in which you will notice or monitor how your network runs, and also how the duration, what duration must it be. So it is also important to monitor for trends that occur over a longer period, such as weekly or monthly. So for this reason, when capturing data for analysis, the period should be at minimum 7 days long. So baseline duration should be as said here, minimum of 7 days long. So lower than that is not optimal. So here are the examples here. This is the CPU utilization. So here first is daily, so hourly here, and a day. So these are examples of monitoring. So next is data measurement. So basically this is the last part. Before we go here, as we have mentioned before, so the duration of baseline is basically essential also, since you could also miss some monitoring, like for example is the duration of monitoring. There may be hidden problems that you may discover if you set the duration of the baseline right. So last is data measurement. So when documenting the network, it is often necessary to gather information directly from routers and switches. Obvious useful network documenting concurrent ping, traceroute, and TNet. So this table basically shows commands that you can use to collect data in the network. So example here is show version. So displays uptime version information for devices, software, and hardware. Show IP internet brief. Show IPv6 internet brief. We have already done this or lectured this before. Show interfaces, IP route, IPv6. So neighbors, running config, VLAN, tech support. So basically these are the commands that we will use CCNA or in networking. So I think that is it. So I'm done with network documentation. That is all. Thank you.